Coronavirus has taken the world by storm lately, affecting the globe nationwide and having a higher contagious rate than any other flu we've ever seen. Today, myself, Massimo Valanzano, and my colleagues are going to discuss COVID-19 statistics in Canada. I will be talking about relative frequency. Relative frequency takes each class of information and converts it to a relative frequency using a percentage or ratio based. Each class is divided by the total number of observations to give you the relative frequency. Let's look at this Excel sheet I created. This is a chart I created in Excel to have a better understanding of the COVID-19 statistics in Canada. To find the related frequency, you take the class you're looking for. In this case will be the total case numbers in Canada, which is 101,019 people, and divide it by the total amount of Canadians tested, which is a big 2,382,781 people, which gives us a related frequency rate of 4.24%. The total number may look big, but in relation to the numbers of Canadians who have gotten tested, it has a low frequency rate. Now on to Amanda with some more COVID-19 stats in Canada.
Thanks, Massimo. Now I'm going to talk about sample standard deviation and population standard deviation. The standard deviation is a measure of the spread of scores within a set of data. Usually we are interested in the standard deviation of a population. However, sometimes we could be presented with data from a sample. I'm going to show you what I created in Excel based off the COVID-19 infections within Canada per province, using a population and using a sample. Okay, so here's my Excel sheet that I created based off of the total confirmed cases of coronavirus in Canada. Up to date, the total confirmed cases in Canada are 101,637. I created a population data based off of all the provinces in Canada. So that's Ontario all the way to the Northwest Territories. I then created a population mean, which is 8,468.67. The population mean is the average of all the cases of the provinces in Canada. Then I create a population standard deviation, which came to 16,701.79. I then divided the standard deviation by the population mean, which gave us a coefficient of 1.97. A low standard deviation means that the data are close to the average. A high standard deviation means that the numbers are more spread out. So in this case, we got 1.97, which is over 1, which is considered relatively high, meaning the data is pretty spread out. If you noticed here, Quebec has 54,835 cases, while the Northwest Territories only have 5. Then I created a sample data. I created the sample data based on about only half of the provinces in Canada, so Ontario to Manitoba. I then found the sample mean, which was 14,451, which again is the average of all of these provinces. Then I did the same thing. I did a sample population standard deviation, which gave us 21,394. And that's all for the population and standard deviation. Now back to my colleague.
How's it going, everyone? I'm Johnny, and I will be talking today about the age by sex distribution of COVID-19 cases in Canada as of June 21st, which is yesterday. So what I'll be doing is calculating the average, also known as the mean, for every case reported, the number of male cases and the number of female cases. So for the first one, what you do is you go to number of cases reported, go to the bottom, go equals average, and then what you want to do is highlight all of the data that you're going to be using, and then end, and right there. So the average number of cases per age group is 12,551 cases. So what that means is every age group usually has an average of 12,551 people that get coronavirus as of yesterday, that got coronavirus as of yesterday. So what I'm going to be doing next is the male cases. So what I'll be doing is, same thing as the other one, I go equals average, and then I highlight all of the data for the male cases from age 19 or under to 80 plus, end it, and the bracket, sorry, enter, and there it is right there. So what that means is that every age group for male cases is around 5,470 people. And then the next thing we're going to be doing is the number of female cases, which is the same thing as what we did earlier. We're going to be doing equals average, and then we highlight all the data we're using, close the bracket, and then press enter. And there we have it right there. So as you can see here with this data, the number of cases per age group for females is 7,038, which is the highest between the males and the females. So what we did with this data is we calculated the average of number of cases reported per age group, below 19 or over 80 plus, just in between there. And then what we did is we did it for the male and female groups, age groups from below 19 to over 80 plus. So as you can see here, like I stated earlier, the number of cases reported, the average is 12,551. The number of male cases average is 5,470 per age group, and the average female number of cases is 7,038.
That's all for my analysis. Now I'll pass it on to Amanda for more statistics.
Hi there, my name is Amanda Grace, and I will be exploring the concept of quartiles and percentiles based off of a data set that focuses on the number of newly reported COVID-19 cases in Canada from the period of June 1st to June 15th, 2020. I retrieved my data set from Statista, and I created a table here on Excel featuring each date in order and the number of newly reported cases for that day. The next step to figuring out the quartiles of this data set is to order the raw data from smallest to largest. I did this using the sort and filter function on Excel. Once the data has been organized, I began by finding the median, otherwise known as middle value. As you can see here, I used the Excel function and inputted the array that I was focusing on. Next, I wanted to find the first and third quartiles. I did this by inputting the Excel function, highlighting the data, and specifying the quartile number that I was searching for. These quartiles separate the data into 4 equal parts, with 25% being below the first quartile and 25% above the third quartile. After discovering the median, quartile 1 and 3, I was interested in exploring different percentiles. I chose to explore the 15th percentile and the 80th percentile. To do this, I entered the Excel function, highlighted the array, and then entered the percentile that I was searching for. It is important to note that you should turn the percent into a decimal for this function. Here you can see that the 15th percentile is 165. This means that 15% of the data is below this number and 85% of the data is above it. And here, the 80th percentile is 431.4. This means that 80% of the data is below this number and 20% is higher. Thanks so much for listening, everyone. I'll pass it over to my next colleague.
Ever since the World Health Organization announced COVID-19 as a global pandemic and a lockdown will be going on, people rushed to their nearest grocery store around the world to buy durable and non-perishable food that will last during the time they'll be staying at home. Statistics Canada had data for the average sales in March 2019 and the average sales of March 2020. Today, we're going to compare the percentage change in the average sales in both years using the simple index and simple aggregate index. I retrieved from Statistics Canada. It includes different types of items sold at grocery stores, like canned fruit, canned soup, masks and gloves, hand sanitizers. These were the key items that were largely sold in the grocery store. And here we have the average sales March 2019 and 2020. The simple index is the measured relative change in one variable compared with a base. Since March 2019 was the previous year, we'll use it as a base, and average sales March 2020 as our new sales. How to find the simple index? We'll divide ST by SO equals sign ST divided by SO for canned fruit times 100. Here we get our simple index for canned fruit. If you want to find for the rest of the values, no need to type the formula again, just drag down, and here you go. Now to find the percentage increase, you will subtract 100 from the simple index. So in this case, for canned fruit, it will be 114.4 minus 100 will be 14.4% increase. For canned soup, 4.6%. Give me a minute to do the rest of the values and I'll be waiting. Here we found the percentage increase for all the items. For example, masks and gloves have been increased by 7.2%, pasta 6.2%, pasta sauces for 16.3%. In order to find the simple aggregate index, we're going to find the sum for all the average sales in March 2020 for all the items listed, as well for all the sales for March 2019. So first we're gonna start off with AutoSum for 2020. Press enter, you get your value. Same thing for 2019. It's very quick and easy. Now we're gonna use the total for ST, total for SO, divide them times 100. Go, select the value of ST divided by SO times 100. Here you get your simple aggregate index up to 1 decimal place, 111.4. If you want to find the percentage increase, it would be the total average sales for all the items increased by 11.4 from 2019 to 2020. Thank you for watching.